Today we are going to study Lemma 3.2.9. Lemma states that let H be a subgroup of the group G for A comma B element of G. Define A relation B if A into B inverse element of H, then relation is an equivalence relation. So we start with proof. If a relation is an equivalence relation, then it is reflexive, symmetric and transitive. Here the relation is reflexive since A into A inverse, that is equal to E is an element of H. It is symmetric since if A relation B, then A into B inverse is an element of H. Since H contains the inverse of each of its element, we have A into B inverse is an element of H. So inverse of A into B inverse, that is equal to B into A inverse, shows that B relation A. Finally, the relation is transitive since if A relation B and B relation C for any A comma B comma C element of G, then both A into B inverse and B into C inverse belong to H. Since H is a subgroup, product of two elements is also an element of H. So here A into B inverse and B into C inverse is also belong to H. That implies A into C inverse shows that A relation C. So hence we have proved that A relation B is a equivalence relation.